One of the best ways to improve your skills is to adopt the mindset of a beginner. No matter how much experience you have, there is always something new to learn. The moment you think you know everything is the moment you stop growing. No matter where you are, there is always room for learning new things. Keep learning and keep growing. So today's topic is on test of significance of small samples. In my earlier video, I have cleared the topic of single mean, and in today's video I am going to discuss about the difference of means. So from seventh example, so already six examples are already taught in the previous videos, and see here, find the maximum difference. See what is it is asked, maximum difference that we can expect with the probability 0.95 between the means of the samples of sizes 10 and 12 from the normal population if their standard deviations are found to be 2 and 3 respectively. So from this, the data given here is N1, the sample sizes N1 is equal to 10 and N2 is equal to 12. And the sample size is S1, so the standard deviation is equal to 2 and the standard deviation here is equal to 3. So here the formula S square is equal to N1 S1 square plus N2 S2 square by N1 plus N2 minus 2. See what is N1 here? 10. What is S1? That is 2 square plus what is N2? This is 12 into S2 is 3 square by N1. This is 10 plus 12 minus 2. The value here is 7.4. So here S value is equal to root over 7.4. So which is equal to 2.73. The standard deviation is equal to 2.72. So next one here is we have to go with the 5 points. We need the maximum difference. So for null hypothesis, as usual, mu1 equal to mu2, alternate hypothesis mu1 not equal to mu2, level of significance 0.05, and test statistics here is t is equal to x bar minus y bar by s into root over 1 by n1 plus 1 by n2. So if you observe, this is the maximum difference. See, we have to find the maximum difference here. So this is only difference we have, and therefore x bar minus y bar is equal to modulus of t times of s into root over 1 by n1 plus 1 by n2. This is for the maximum difference formula. So I have sent this denominator to the numerator here. So here what is t here? So modulus of t, the calculated value is equal to 2.086. And what is the standard deviation? This is 2.72. Root over 1 by n1. So what is n1 here? So n1 is very clear as 10 and n2 is very clear as 12. So here, if you observe each and every value, the value here is 2.43. See here, the calculated value for t here is nothing but for the degrees of freedom. This is n1 plus n2 minus 2. So the formula here is n1 plus this is n2 minus 2. What is n1 here? So n1 is equal to 10 plus n2 is equal to 12 minus 2. The value here is 20. At 20 at 5% level of significance. See here. So this is the t distribution table here. For degrees of freedom, we have to go with 20. And for 5% and 5% level of significance, the value here is 2.086. So this is the value for t. I have taken 2.086, and for standard deviation is 2.72 value, n1 and n2. So n1 is very clear as 10 and n2 is very clear as 12. So that we will be getting 2.48. So this is the maximum difference. So the maximum difference, we have to find the maximum difference, and the maximum difference value is 2.43. Hence the maximum difference between the means is 2.43. That is one kind of problem. And the next one is example 8. Two independent samples of 8 and 7. So here it is very clear that n1 is equal to 8 and n2 is equal to 7. Items respectively had the following values. So this is sample 1 and sample 2, and these are all the values. Is the difference between the means of the sample significant? So this is also very important. So n1 is given as 8 and n2 is given as 7. First we have to find out the mean values and the standard deviation. For finding the mean x bar, so this is x bar. So we have to add up all the values divided by 8. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8, the value here is 12. So we got x bar value as 12. And whereas y bar, so we have to add up all these values, that is 9 plus 11 plus 10 plus 13 plus 9 plus 8 plus 10 divided by 7. The sample size here is 7, and therefore we got the value as 10. Therefore we got the value of y bar is equal to 10. For finding the mean and the standard deviation, see here the first column is filled with the data x bar and we have to subtract 12 from each and every value of x. 11 minus 12 is minus 1, 11 minus 12 is minus 1 and 13 minus 12 is plus 1. So that we'll be filling the second column and we have to make the squares out of this. Minus 1 square, minus 1 square, 1 square, minus 1 square, 3 square, minus 3 square, 0 square, 2 square. So now after adding the value here is 26. So these are all the y values from the question and y bar is the mean value here is 10. So we have to subtract each and every value from 10. That is 9 minus 10 is minus 1, 11 minus 10 is 1 and 10 minus 10 is 0, 13 minus 10 is 3 and so on. We have to fill this column and we have to make the squares out of this, and after making an addition this is 16 value. So we need the standard deviation. First of all I am going to find out the variance. S square is equal to sigma x I minus x bar whole square plus sigma, this is yi minus y bar whole square divided by n1 plus n2 minus 2. The total here is 26, the total here is 16 divided by what is n1 here. So n1 is equal to 8 and n2 is equal to 7. So this is n1 plus n2 minus 2. 8 plus 7 minus 2, the value here is 3.23. So here this is s square value. If I make a square root of 3.23, the standard deviation here is 1.8. So we have x bar value is equal to 12 and y bar value is equal to 10. So now we have to go with the 5 points. The first one is the null hypothesis. Null hypothesis here mu1 equal to mu2, alternate hypothesis mu1 not equal to mu2, level of significance, alpha is equal to 0.05, test statistics x bar, t is equal to x bar minus y bar by s into root over, so this is most important, s into root over 1 by n1 plus 1 by n2, x bar is very clear as 12, y bar is equal to 10, standard deviation is equal to 1.8 root over 1 by 8 plus 1 by 7, the value here is 2.15. So for the degrees of freedom here, the formula is n1 plus n2 minus 2. The degrees of freedom is 13 at 5% level of significance from the table. See here, this is the t distribution table for the degrees of freedom 13 at 5%. So go with 13 at 5% level of significance. The value here is 2.160. The value here is very clear as 2.16. So this is the calculated value and this is the tabular value. Clearly 2.15 is less than 2.16. Therefore the calculated value of t is less than tabular value and therefore we accept h naught. Therefore the conclusion here is the difference between the mean samples is not significant. Clear? And the next question, the ninth question here is measuring specimens of nylon yarn taken from the two machines. It was found that 8 specimens from the first machine had a mean denier of 9.67 with the standard deviation. Standard deviation is 1.81. While, see here, the next data here is while 10 specimens from the second machine had a mean denier of 7.43 with the standard deviation of 1.48. And now, see here, assuming that the proportions are normal, test the hypothesis. H naught is equal to mu1 minus mu2 is equal to 1.5 against H1 is equal to mu1 minus mu2 is greater than 1.5 at 0.05 level of significance. So this is the question. So this is from the machine 1 and this is from the machine 2. See, it is very clearly mentioned that 8 specimens. So N1 is given as 8 and the next one here N2 is given as, so 10 specimens. N2 is given as 10 and X bar is equal to, the mean is given as 9.67 and Y bar is given as 7.43 and S1, the standard deviation is given as, first one is 1.81 here and S2 is given as 1.48. When the mean and the standard deviation are directly mentioned, then the variance S square is equal to N1 S1 square plus N2 S2 square by N1 plus N2 minus 2. This is the formula which you have to remember. So if I substitute, what is N1 here? 8. What is S1? 1.81 whole square. What is N2? 10. So this is 10 into 1.48 whole square by N1 plus N2, that is 8 plus 10 minus 2. The value here is 3.007. So this is nothing but S square. So here N1 8, N2 10, X bar is equal to 9.67, Y bar is equal to 7.43, S1 is equal to 1.81, S2 is equal to 1.48. Clear? And here the standard deviation, variance here is 3.007. For standard deviation we have to make a square root. After making a square root, the standard deviation here is 1.734. So here the delta, the difference between mu1 and mu2 is 1.5. X bar is this one, y bar is this one. Standard deviation is 1.734. N1 is equal to 8 and N2 is equal to 10. And now we have to go with the 5 steps here. First one is the null hypothesis. Mu1 minus mu2 is equal to 1.5, which is equal to delta. And alternate hypothesis, mu1 minus mu2 is greater than 1.5. Level of significance, 5% level. Test statistics, T is equal to X bar minus Y bar minus delta. So here you have to remember this extra part delta here. So this is the formula here for this type. X bar minus Y bar minus delta by S into root over 1 by N1 plus 1 by N2. So all the values are ready. What is X bar here? 9.6167. Y bar is equal to 7.43 minus delta. Delta value is equal to 1.5 divided by standard deviation here is equal to 1.734 root over 1 by N1, 1 by 8 plus 1 by 10. The value here is 0.8997. So here for degrees of freedom, that is N1 plus N2 minus 2. So here 16 degrees of freedom at 5% level of significance. The value here is, see, this is the T distribution table at the degrees of freedom. So 16 degrees of freedom. So we have to go with 16 degrees of freedom. And next one is 0.05 level of significance. That is 1.743. It's at 5% level. This is 1.746. When you compare these two, the calculated value is smaller than the tabular value, and therefore the calculated value of T is less than the tabular value. We have to accept H naught. So this is how we have to solve. And the next question 10 here is 10 soldiers. So here 10 is also a numeral underline. 10 soldiers participated in a shooting competition in the first week. After intense training, they participated in the competition in the second week. Their scores before and after training are given as follows. Scores before and scores after. So these are all the scores given for 10 soldiers here. So N1 is equal to 10 and N2 also 10. X bar is equal to, so X bar is nothing but we have to add up from 67 till 43 divided by 10. So the value here is 52. So X bar value is very clear as 52, and Y bar is equal to the mean of the scores from 70 till 38 you have to add, and we have to divide it by 10. The value here is 57. So Y bar is equal to here 57. Now we have to compute the standard deviation of the two samples here. For finding the standard deviation, these are all the X values. So X bar, so we have to subtract 52 from each and every value of X column. That is 67 minus 52 is 15, 24 minus 52 is minus 28, 57 minus 52 is 5, 55 minus 52 is 3. So we have to fill this column and we have to make the squares. And this is obviously the total here. So you can use your calci, and this is the procedure I am explaining you. So these are all the Y values from the question, and Y bar. So Y bar is 57. So we have to subtract 57 from each and every value. 70 minus 57 is 13. 38 minus 57 is minus 19. 58 minus 57 is 1. Like that we have to fill this column and we have to make the squares. That is 13 square minus 19 square, like that. And we have to make a squares out of this. So here the variance is equal to sigma xi minus x bar whole square plus yi minus y bar whole square by n1 plus n2 minus 2. So here clearly n1 is equal to 10 and n2 is also 10. So here the total here is 1882 plus 1664 divided by 10 plus 10 minus 2. The value here is 197. So this is the variance here, s square. So if you make a square root, the standard deviation here will be 14.0357. And as usual, we have to go with the 5 steps here. First one is the null hypothesis. Mu1 equal to mu2. There is no benefit of training. Alternate hypothesis. Mu1 less than mu2. There is a benefit of training. Level of significance. As usual, alpha is equal to 0.05. Test statistics. T is equal to, see here, every time we'll be getting this formula, x bar minus y bar by s times of root over 1 by n1 plus 1 by n2. What is x bar here? Say x bar, just now we found out as x bar is equal to 52 and y bar is equal to 57. So clearly x bar is equal to 52 and y bar is equal to, this is 57. Standard deviation here is, this is 14.0, this is 14.0357. And the next one here is n1 is equal to 10 and n2 is also 10. So we have to substitute all the values here. After substituting, the value here is minus 0.796. So here the degrees of freedom n1 plus n2 minus 2, 18. At 18 degrees of freedom, at 5% level of significance, This is, see here, for T distribution for 18 at 0.05 level of significance, clearly it is 1.734. So this is 1.734. So if you take a modulus, this is 1.734, and this value is nothing but the calculated value, and this is the tabular value. Clearly 0.7 is less than 1.7, and therefore we accept the null hypothesis H naught, and therefore the soldiers have been benefited by the training. That is the conclusion part. And the next one is the 11th question. To compare two kits of a bumper gods, 6 of each kind. See here, 6 of each kind were mounted on a car. Then the car was run into a concrete wall. The following are the cost of repairs: God 1 and God 2. See here, this is the data given. So we have to use 0.01 level of significance to test whether the difference between the two sample means is significance. This is also important. See here, from the question, n1 is equal to 6 and n2 is also 6, x bar is equal to, we have to add up the given data divided by 6. The value here is 127.33. X bar is equal to 127.33 and y bar is equal to clear. So we have to add up the data and divide it by 6. The value here is 129. So this is the x value. This is x minus x bar. From each and every value we have to subtract 127.33. So this is 127.33. So this is minus 20.33. 148 minus 127.33 is 20.67. So we have to fill this column. We have to make the squares. And here this will be the grand total here for x bar minus x bar. So this is the y values from the question. So y bar here is 129. So we have to subtract 129 from each and every value here. This is 127.33. We have to subtract. So this is 134 minus 129 is 5. 115 minus 129 is minus 14. So like that we have to make a subtraction after making the squares. This is 1010. So this is the variance value, sigma xy minus x bar whole square plus yi minus y bar whole square by n1 plus n2 minus 2. So these two are the totals you have to add up, and 16 plus 6 minus 2. So n1 is also 6. So this is 6 plus 6 minus 2. The value here is 12 minus 2 is 10. The value here is 399.934. So this is the variance value. So if you make a square root, then the standard deviation value is 19 point. So if you make a square root, so that is root over 399.934. So if you make a square root, the value here is 19.998. So as usual, we have to go with the 5 steps. First one is the null hypothesis, mu1 equal to mu2, alternate hypothesis, mu1 not equal to mu2, level of significance, alpha is equal to 0.01, test statistics. So this is the formula. Every time we use T is equal to, for difference of means, x bar minus y bar by root over, by s into root over 1 by n1 plus 1 by n2. Clearly x bar. So x bar is very clear as 127.33. So this is 127.33, and y bar is very clear as 129, and standard deviation here is 19.998 by root over n1 n2. So n1 is equal to 6 and n2 is equal to 6. After substituting, we got the value as minus 0.1416. So this is the calculated value. For tabular value here, at 10% level of significance at 0.01. The value here is, see, the value here at 10% level of significance. We have to go with the degrees of freedom table. For 10, the value here is 3.169. So here the tabular value is 3.169. So if you compare with any value, so this value will be smaller one. The calculated value is less than the tabular value. Therefore, we accept the null hypothesis H naught. And therefore, there is no significance difference between the sample means. So these are all the problems related to the difference of means. So I have uploaded 3 videos related to this series. Don't miss those videos. These are all the problems from the textbook. Definitely each and every problem is of different kind. So if you follow these videos or just you listen and you go through the textbook, definitely your preparation will be damn easy. And hope you will all subscribe to this channel and stay connected for more videos and for more preparation. Please share this videos to as many friends as you can. That is the greatest help needed. Thank you so much for staying till the end.